Hi everyone, this is a new topic, simultaneous equation, a bronze topic. This is week 8 now on your planner, and it's either a foundation or a high tier level question, more or less guaranteed to come up. Now the 3 different learning objectives we need to hit through this lesson are these 3 things over here. We have a basic type of simultaneous, an advanced, and a worded kind of question where you need to find the maths or the simultaneous within that worded structure. This is grade 4 to 5. As we said, we're on week 8 here. Here's a little space for your best examples and 3 steps. Hopefully we'll get together by the end of this topic. So make sure your revision card looks like this, your template. Let's turn over, guys, to see how we can structure our toolkit. So on your revision card, let's write the toolkit 2 separate sections, A and B. We're going to be using these to fill in our best tools and methodologies to help you get through this core kind of questions. So press pause and make space for these 2. Question 1, back to basics, simultaneous equations with elimination. Let's find the value of x and y. Press pause right now. Press play when you found these 2 values. Now, a simultaneous equation, the way you identify this, you always have an x, a y, and a number equaling each other, both linear equations. So first of all, let's try to label these A and B, or 1 and 2, whatever is your preference. Now, the first thing we do is look at the variable, which has the same coefficient in front of it. So, cutting the jargon down, basically you look for the same numbers in front of the letters. Now, here we have the x's, okay? There's an imaginary 1 and a 1 over here. Let's circle this. Let's say red. Okay, so it's always going to have a circle around one of these variables. Now, what you want to do is eliminate. Eliminate means to get rid of this x variable. So the way we do that is this. Let's put a line over here. Let's decide what do we put in the middle to get rid of these x's. Do we put a minus in the middle or a plus? It's pretty obvious it's a takeaway. So it's a minus. We put a minus here and a minus there. It's very important you put minuses in all 3 columns, as it were. The x's, the y's, and the numbers. Now let's do the math. So what's 1x take away 1x? It's / or 0x. We don't write 0x, we'll write / it's a bit easier. 2y take away y, or 2y take away 1y. Same thing as 1y, or let's write y in fact. 7 take away 6 equals 1. And the answer is 1. That's the half the story. We've got x. We've got y, let's find out x. So to do that, let's substitute this value of y into either equation number 1 or number 2, whatever looks easiest. Well, they're both pretty easy. Let's just sub it into number 2. So we're going to write this, x plus, now wherever we see y, we're going to write 1. We sub in y for 1. X plus 1 equals 6. Let's make x a subject. X equals 6 minus 1. X equals 5. Now, this is a very, very simple example, yet it shows the basic structure of what we do and how we apply this in this basic type of simultaneous equations. So make sure you understand this process. Question 1, Core 1, simultaneous equations. Let's press pause. Let's write this question down. Let's find x and y. Press play when you are ready. Now this question is a typical basic style question on simultaneous equation. And let's look at this. It's a bit tougher than the back to basic question we had previously. Now the first thing, let's label each one. Let's identify them obviously and label them number 1, number 2. What is the value of x and y in both of these linear equations? Now the first thing, let's look at the variables. Which ones can we identify with the same sort of number before that? Now when we say same, we don't mean exactly the same, but it could be a difference in the sign. One could be a plus, one could be minus. It's definitely going to be the y variable over here. We have a +2 and a -2 on the y variable. Let's circle this. This is what we want to do. So we want to eliminate the y variable over here. Let's decide now how we can do that. Do we put a plus, 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 or minus, minus, minus in between them? Now, it'll be a plus because +2y plus -2y is going to be 0y. We'll put that over here just so you understand this. Because a minus and a plus, so plus and a minus in this case, will make 0y. Any sign that's different, by the way, a sign change over here, is going to be a plus. So this is plus, and this is plus as well. Let's plus all the three columns respectively. 3x plus 4x, this is going to give us 7x. And 2y plus minus 2y will give us / or 0y. 8 plus 6 is going to give us 14. X is simply going to give us an answer of 2. So x is 2. Let's do the second step now. Let's sum this into the easiest linear equation. This will probably be number 1 because it's simply got a positive coefficient of 2 here. So wherever we see x, we're going to sum in 2. So this is 3 times x. I'm going to write 3 times 2 over here. Plus 2y equals 8. So 6 plus 2y equals 8. 2y equals 8 minus 6. Look how we did that. The plus 6 becomes minus 6. And therefore 2y equals 2 and y equals 1. You can always test this if you want to in number 2. 4 times 2 is 8. Let's try to check over here. You don't have to do this. If you have spare time, it's definitely worth it. If x is 2, 4 times 2 is 8, minus 2 times 1, because y is 1. We should get 6. So this is 8 minus 2. It's 6. And this is 6, obviously, over here. So that's how you do this basic style simultaneous equation. So this is a summary box, and this is pretty useful for any kind of simultaneous equation, being basic or advanced when we talk about elimination. Now we have 4 different types. We have plus, minus, plus, and minus. You need to know the circle bit in the middle, okay? What sign to use when you have this to eliminate your variable, okay? So same sign, subtract, a little hint we have over here on maths memory, SSS in red. That should help you as well. So press pause, make sure you digest this. This will hold you in good stead for the questions to come. Question 2, core 2 is simultaneous equations. Press pause, let's write this question down. Find x and y. Press play when you are ready. Now let's find out x and y. Here we have an advanced style simultaneous equation. And the way we identify the difference between a basic and an advanced simply has different coefficients, let's say on each of the variables, different numbers on x and y. Let's look at this. Now we want to make the let's say the coefficients the same on either x or y. How do we do that? Because they'll always be different in an advanced question. Well, this is how we do this. Now, first of all, let's choose if you want to look at the x's or the y's, okay, to make them the same. Now, a little trick over here. We're going to look at the top equation over here and think, what can we multiply this by to make it look like this 4 over here? That's a much easier way of doing it like this. So we're going to create a new set, number 1 and number 2. We'll call this a new, okay? This is the only new step we do for advanced simultaneous. We're going to multiply everything here by 2 and everything here. In hindsight, we're going to get this to a 4y. Hence, we could eliminate those with the same coefficient. So everything over here, let's times it by 2, by 2, by 2. 4x times 2 is 8x. 2y times 2 is plus 4y. 11 times 2 is 22. Over here with the second equation, 5x times 1 is 5x. In fact, you can just write it the same because everything times 1 is simply itself. So this stage should be familiar to you. This looks like how the basic style would look like, i.e. we have the same coefficients on the y variables. Let's think to ourselves, how can we eliminate the y's now? So this is simply a minus over here because 4y take away 4y is 0y. Let's take away all the respective columns together and let's do this together. Now 8x take away 5x is 3x, 4y minus plus 4y / 22 take away 13 is 9. Hence 3x equals 9, x equals 3. Now that's the first step. We've found out the value of x. Let's find out y by subbing in into our original set of equations. You could sub them into the new ones, but that would be a lot more cancelling down, so always do it on the first set. That's what we advise here in Maths Memory. So let's find out which ones looks easier. I think number 1 looks slightly easier in this case because of the lower numbers. It doesn't really matter which one you sub it into really. So let's sub it into number 1. So wherever we see x, we simply plug in 3. So it's 4 times 3. Remember that 3 there is the 3 over here. Plus 2y equals 11. 4 times 3 is 12. So 12 plus 2y equals 11. Let's get all the x's on one side, all numbers on the right. So this plus 12, let's shift over to the right hand side to make 11 minus 12. 11 minus 12 is minus 1. Let's get this into a fraction. Now this number, this coefficient will always be underneath because you're timesing it by 2 on the left. You do the opposite, you divide it by 2. Y equals minus 1 over 2 or minus 0.5, whatever you prefer. Let's write minus a half as a fraction. That's the same thing. Okay, so that's how you do advanced style simultaneous equation. Now look back at that. The only extra step is this one, as we said, but it's pretty much the same thing as basic, but it's shifted up to a grade 5. Question 3, core 3 simultaneous equations. Press pause, let's find out x and y on the simultaneous. Press play when you have completed this. Now this is a style of an advanced simultaneous again because we have different coefficients on the x's and the y's if you look at these respectively. So let's choose either the x's or the y's first, and let's multiply these coefficients together. Let's choose the x's. You can choose y's if you want to. We'll choose the x's in this case. It doesn't really make a difference what we choose. So what we'll do, we'll create a new set and multiply everything by the other coefficient on each one of these. So this is slightly different from core 2, where we took a different style on advanced simultaneous, but this is a probably more concrete way of understanding it in terms of this will work in every situation if all 4 are different, that is, okay, and not multiples of each other. They're all not related. So let's create the new set, number 1 and number 2. Number 1, let's multiply everything here by 3 because it's the other coefficient of this equation over here, and let's multiply everything here by 2 because it's the other coefficient of this one. So everything here by 3, 6x minus, let's say 12y equals 57. And this one over here, multiply everything by 2, it'll be 6x plus 10y equals 2. Let's now decide if it's a plus 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 or minus minus minus. Now the same coefficients are on the x's over here, so it's definitely a minus, and a minus. Let's take them away from each other now. So 6x, take away 6x, this will simply give us 0x or forward slash minus 12y minus 10y. This will give us minus 22y. 57 take away 2, 55. Well, y would be 55 divided by minus 22. So as a mixed fraction, let's convert this top heavy to a mixed fraction. This would be y would equal, how many 22s are in 55? Just ignore that minus for a minute. It'll be 2, remainder 11 over 22, which is simply 2.5. Okay, and this would be a minus because a positive divided by negative always gives a negative. So 2.5 is the answer. Y would be minus 2.5. Let's sub this into now either 1 or 2 on our original equations to find out the value of x. Now let's sub this into our original equations over here, either 1 or number 2, whatever's easiest. We'll sub this into number 2 simply because of the positive coefficient over here of y. It doesn't really matter which one we do it though. So sub into number 2. Wherever we see y, we're simply going to replace this by minus 2.5. So this will be 3x plus 5 times 2.5, put a minus there, and this will be equaling to 1. Now 3x 2.5 times 5, put a negative in front of it, it will be minus 12.5 equals 1. 3x therefore would equal, let's get 1 plus 12.5, 3x would equal 13.5. Hence, x would be 13.5 divided by 3. How many 3's are in this? Like a top heavy? Well, it goes 4 times to make 12. So the answer is 4. 1.5 over 3, which is simply going to be 4.5. So x is 4.5. So quite a tricky one. Both of them are 0.5s. X is 4.5 and y is minus 2.5. Question 4, challenge simultaneous equations. Let's write this worded question down. Let's try to write the maths behind the words and try to solve for x and y, or t and c in this case, t and coffee. Press play when you're done. Now 3 teas and 2 coffees have a total cost of £7.80. 5 teas and 4 coffees have a total cost of £14.20. Work out the total cost of 1 tea and 1 cost of coffee. Alright, so let's first of all structure this in terms of a simultaneous equation. Let's try to find out two variables. They're quite easy to find. T for T's and C for coffees. Let's do number one. Alright, so we have 3 T's. Let's abbreviate T's for T. And 2 coffees. Let's abbreviate coffees for C. And this is a total cost of £7.80. No need to put the pound sign there. Equation number 2, it's the second line over here. 5 T's, so 5T plus 4 coffees equals £14.20. Now this is an advanced style simply because we have all different coefficients on our variables. Let's now create a new set. I'm going to write new over here, and number 1 and number 2. Now if we look at this, we're going to choose the C's over here, and because they both are factors of each other, multiples of each other should we say, we can times this top row, number 1, by 2. Okay, so in hindsight, we want to make that a 4C as well. So we're going to multiply everything here by 2 and leave this one the same over here. 60 plus 4C equals, we double this, £15.60 times by 1, same thing, 5T plus 4C equals £14.20. Let's look at the C's now, because the C's have the same coefficient, and we simply take them away because it's a plus 4C and a plus 4C as well. Take them away from each other. So 60 take away 5T. This gives us 1T. This is 0, and this take away this will give us 1.4. £1.40. So that's how much a cup of tea is. Okay, let's find out C. So to do this, we're going to sub in now something over here. We're going to sub in into either 1 or number 2, whatever looks easiest. We'll go into number 1. So sub in number 1, wherever we see T, we plug in £1.40. So 3 times 1.4, let's say, plus 2C equals £7.80. If we triple this, we get 4.2 plus 2C equals £7.80. Let's make C the subject. 7.8 take away 4.2. So 2C will therefore give us £3.60. C therefore is £1.80. That's how much the cost of coffee is going to be. So again, this is a worded question. We need to go back and look into how the words fit into these maths questions, or let's say it's the maths setup over here. Here is our completed revision card, which you should have now, and make sure you have these things jotted down on your card. We have already learned basic simultaneous equations, how to identify them with the same variable, advanced simultaneous, how they come in different variables to begin with, and what to do to create your new equations, and worded questions in a context. Here's an example. A space, again, you should have your best example filled in here, and here are your 3 steps to tackle any kind of simultaneous equations on maths memory. First of all, step 1, choose basic or advanced. What is it you want to find out? Is it a grade 4 or grade 5 question? Apply a summary box. We showed you 4 different scenarios. What would it be? And we showed you SSS as well, a little trick for that. Same sign, subtract. Then substitute to find the other variable, your x or the y variable, depending on what you've originally did. So please press pause on this, and let's turn over to make sure you have your toolkit jotted down as well before we start our Let's Do It questions. Here is our summarized toolkit now. So let's make a note of this, pause the video, summary box, and basically how to identify your basic and advanced simultaneous equations. So pause this, I'm going to be using this towards our Let's Do It questions in your own way. Question 1, let's do it, simultaneous equations. Let's now use our revision cards. Let's use your toolkit to identify your steps 1, 2, and 3. Your method should be sound. Let's apply this to this section over here to make sure we've clocked it. Press pause, write this question down, and press play when you're done. Question 2, let's do it. Press pause, write these simultaneous equations down. Try to find x and y. Press play when you have finished. Question 3, let's do it. Press pause. Let's try this third question. Press play when you are ready. Question 4, let's do it. So let's interpret this word question into a simultaneous equation and find respectively the cost of a sandwich and a crisp packet. Press play when you have finished. Congratulations on finishing this topic on simultaneous equations, and this is by elimination. So how well did you do? How well did your cards serve you on those last Let's Do It questions? Did you get them right? Did you understand basic and advanced simultaneous equations? Your summary boxes, your toolkits. If it did you justice, this topic, and you feel good, give yourself a good mark out of 10 on that revision planner of yours.